are. Yeah, opposite of this. So don't include the left, include the right. Or include both. This is called an open interval. This is called a closed interval. These two are called half open or half closed. You can say it both ways. This is a half open interval or a half closed. This is half open, half closed. It doesn't matter how you say that. But we can have one of those four possibilities. All right?
Do the intervals have to be like definite numbers, or can they be infinity?
No, they have to be definite. These have to be fixed numbers. These have to be real numbers. You can't have like 2 to infinity. Okay, good question. If it's going to involve the whole, like in one direction forever, it's got to go both directions forever. I had a student in my other class ask me, can we have multiple intervals? Like, can it converge on an interval over here and an interval over here separated? No. It converges on an interval, single interval, all right? A single interval. Yes?
So when we have the part 3 there,
Uh-huh.
that's when we know when to check and plug in the number.
Yeah,
and,
yep.
Figure out which one's working.
Yeah. So when you're doing these power series and trying to check for convergence and divergence, you're kind of hoping for these two cases. Because when these two cases happen, you've got your answer right after the ratio test. But if you get an interval, then you're going to have to actually check endpoints to figure out, whether or not they work. So these are more work. And I'm going to do another example, don't worry. But I still need to continue talking about the interval over here. Okay? So if we have interval, okay, so if it's an interval, then there exists a number, capital R, that is called the radius of convergence. That is the series converges if the absolute value of x minus a is less than capital R. I'm going to explain this, okay? I'm going to talk about the example we just finished up. I'm going to explain what this means, all right? There's some number called the radius of convergence, so that as long as this is true, then we have convergence. Further, the interval a minus r, a plus r, or a minus r, a plus r, or a minus r, a plus r. You get the idea? Or the interval a minus r, a plus r. So this is these four different possibilities, right? These, whichever one this is, okay, is called the interval of convergence. Interval of convergence. So we have two new definitions here. The interval of convergence and the radius of convergence. The radius of convergence is just a number, and the interval of convergence is an actual interval. It may include both endpoints, one endpoint, no end, right? That's going to depend. So generally speaking, if you're asked to find the interval of convergence, it's actually, that guarantees you a lot of work right there, because that means you need to figure out which of these four cases it is. All right, so let's go back to the problem we just had. The last example that I just did, this right here, And let's make sure we change that n down here to 1. Okay? And let's talk about the interval of convergence here. Or sorry, the radius of convergence. What is the capital R? Well, the capital R, remember, comes from this. Right? That's the little expression we have where it has capital R in. It says this thing converges as long as this is true. So do you remember seeing that anywhere? When we were doing the work? When did we have that? After the ratio test and the limit and all that, didn't we come up with this? Didn't we say we had 2x plus 3 less than 1? Didn't we actually have that? Now, that is not R. R is not 1. Because don't all these problems, I would use 1 over here? Right? All the problems would have 1 here because ratio test. So it can't possibly always be a radius of 1. What I need to do is take this absolute value inequality and make it look like this. And to do that, you basically need to make sure you have a coefficient of 1 on x. So let's try and get a coefficient of 1. How about we factor a 2 out of that? If I factor a 2 out, I can actually bring it out of the absolute value. And when I have that, yeah? And now, divide by 2. Now can you see this over here? This right here? Isn't that it? What's A? Careful. What's A? Negative 3/2. What's capital R? 1/2. So you have capital R is 1/2. The radius of convergence is 1/2. Now let me try and explain what this number actually means, okay? Because this is an important number, but why? So do you remember what the interval was that we had? We had -2 and -1. We included that, right? We didn't include this, and it was everything in here, right? Okay, what is the A here? Negative 3/2. Negative 3/2 is negative 1.5. Isn't that right here in the middle? Negative 3/2. Okay, if I asked you to measure, almost like a circle here, I realize it's not a circle, but when we think of radius, we think of circle, don't we? Radius, if I say go out each direction 1/2, where would you be? -1 and -2, right? So the distance from here to here is 1/2, distance from here to here is 1/2. So it's kind of like if you're looking at the center of your interval of convergence, you've got 1/2 in each direction is your radius of convergence. Got it? All right, so what is the interval of convergence? What is I? Yeah, that we already did all the work for. So it's just -2 to -1, but with closed open, right? All right. I think we're ready for an example. Another example. By the way, while I've got this up here, we had, for the theorem I just put up on the board, part 1, part 2, part 3, right? Part 1, we said, is, what would happen in part 1? Converge at a single point, right? What do you think? Do you think I have a radius of convergence if that happens? If I told you you have to give me a radius of convergence for that situation, what would you give me? 0. Okay? So you could look at this as a radius of convergence of 0. Because, again, your answer is a single point, right? If I ask you how wide is that, you would tell me 0 wide, wouldn't you? So in the case 1, your radius of convergence is said to be 0. What do you think we call the radius of convergence in the case 2? Infinity, both ways. You have an infinite radius of convergence. And then, of course, In the last case, if you're on an interval, all I can say is that it's a positive number, right? And not infinity. Make sense? So that means, you're walking down the street and some guy bumps into you and he's like, hey, what's the radius of convergence of a power series that converges at a single point? You'd be like, 0, man. Don't bump into me, right? That's just general knowledge now. All right, let's try one of these. Let's go with this one. This is the only example I'm going to give you. Okay, so I've done 3 already. I'm going to do one more. We're going to run it the whole way through, right? And then I'm going to send you off with your homework. The homework solution videos for this section I think are going to be very useful because there's a lot. I'm going to give you the homework assignment. There's a lot of problems, but every single one of them I'm doing the same exact thing, right? Checking the ratio test, hoping to get case 1 or 2. When it doesn't happen, I have to run the endpoints through and come up with some sort of tests. So I could do this for the rest of the semester. We could come into class, right, every single day for the rest of the semester, and I could give you example after example of ratio tests. But at some point, you gotta just get in there and get your hands dirty. There it is. All right. There's your power series. Here's what I want. Find R. Find I. 2 different instructions here. Basically, to get them, we're gonna have to do some work, right? Ratio test first. Limit n goes to infinity. Do you think it was me kicking the desk that actually stopped that thing from flickering? What is this? What is that? What is that? That. That's a sub n plus 1, right? Sorry, I just wanted to know, what did I just write there? Why did this become 2? What's going on here? That's a sub n plus 1, right? Then I'm dividing by a sub n, which means flipping it. So square root n plus 1 over negative 5 to the n, x to the n. So that's a sub n plus 1 over a sub n, but flipped over for us. What do you want to do with this? Split it. A bunch of these n plus 1 powers are really helpful because they allow me to split up. So let's go ahead and split them up here. I'll just kind of go, this is really negative 5 to the n times negative 5. This is really x to the n times x. Y'all agree? And we get some good cancellation there. Negative 5 to the n, negative 5 to the n, x to the n, x to the n. This negative 5 to the n that we had, if it was negative 1 to the n, would I have even cared? I wouldn't have even cared if it was this. Because no matter what, that's absolute value of that's going to be 1. So I don't even have to worry about it. But when it's negative 5 to the n, I do have to worry about it because that does matter when I take the absolute value because of the 5, right? So just be aware of that. That's why I didn't just kill them off to begin with. All right, now let me rewrite this limit. I should have stuff with x's. I should have stuff with n's. So let's do the n stuff first. Root n plus 1 over root n plus 2. I also have a negative 5, right? So why don't I do this? I put the negative 5 here. Root n plus 1 over root n plus 2. Yeah, I'm doing the n's first. I'm separating them, right? I'm always going to put my n's before my x's. So then times, now what was the x thing I missed? Just x, right? So here's x. I like to do that because I don't care about the x, right? I care about this. And what is that limit doing? Infinity over infinity? Okay. Now, if I were doing this, I would actually put those into one root, right? Because we can do that. If you have a fraction with two roots, you can make one big root out of it. The reason I like that is because then when I do my limit, I can go inside of it like this. And what's this limit in here? It's going to go to 1, right? Infinity over infinity, but L'Hopital one time, we're there. So that's 1, root 1. So just 1 there, but we still have the negative 5. So after you apply the limit, do you agree that we have this? Absolute value, negative 5x must be less than 1. Limit's gone, right? Unfortunately, this is not case 1 or 2, right? If it was case 1, what would have happened? Do y'all remember what happened when in the case 1 with this part of the limit? Do y'all remember what it went to? If this goes to 0, you're in case 1. Okay? What if this goes to infinity? Case 2. If this goes to a number, you're in case 3. All right. This is really this, because you can take the absolute value of negative 5, which is just 5, then bring it out. And then I'm going to divide by 5. Absolute value of x is less than 1/5. Why am I doing all this? Why didn't I just leave it like this? Why am I taking it all the way to this right here? I'm trying to get my interval, but I'm also trying to get my radius of convergence. And to get radius of convergence, I need it to look like this, right? Which means I needed a coefficient of 1 on x. So I had a coefficient of negative 5. I need that out of here. So I got it out and divided through. Now, does this look like that? Yes? What's r? 1/5. What's a? 0. So remember, this is x minus 0 here. Okay. So right now, at this point, I can actually answer one of the two questions. R is 1/5. I'm done with that part. But now I need the interval. So to do the interval, I continue my work, and I rewrite this negative 1/5 less than x less than 1/5. And now I need to check these two endpoints. I need to check negative 1/5 into that series and 1/5 into that series. They may work. One may work, the other may not. They may both not. It just depends. Every series is a little bit different. All right. Let's go ahead and check x equals negative 1/5. So I'm going to rewrite my series. I'm replacing x with negative 1/5. So it's negative 5 to the n, and then 1/5 to the n over square root of n plus 1. Any ideas of what we could do with that? I find that funny. Have you all read that? That just seems funny to me. We thank you for erasing the board at the end of your lecture. Please do not erase. One of my favorite things I've ever seen in like a bathroom stall was this list of, it said something like, things I hate. And it was like a list of all these things that this guy hated, I guess. And at the very end, his last thing was lists. I don't know, that kind of reminds me of that. All right, never mind. My mind wanders. I'm letting you try and figure out what the heck's going to happen here. Okay, combine the top together. So what would it become if you combine the top together? It would be negative 1 to the n. Right? Since they're both raised to the n, you can put them together, and negative 5 times 1, are we doing, oh, we're doing negative 1/5. My fault. This was negative. Maybe I should pay attention. Maybe I should just pay attention up here and stop looking at doodling on the walls. Okay, so now this